All right, we're back. We're actually on page 57. I've copied, so you got to go back and watch the last two videos if you want to see where these things have come from, but I copied them in. So we have our limited, so this is really important. This is the graph. It's the limited one-to-one graph of sine. This is not the graph of arc sine. This is the graph of sine where it's one-to-one. Now the information that we're going to have is actually about arc sine. So I can understand where that's a little confusing, but this page and the next page are like really similar, just kind of like refocus it. You have to like think of it in a lot of ways. And so that's what I'm trying to do here. So based on this, right, the domain here, so this is a one-to-one sine, right? The domain of this graph is negative pi over 2, inclusive to pi over 2, inclusive, and the range of this graph is negative 1 to 1, which it better be, right? Because our whole goal, like our primary mission was to keep the range. We had to have the range the same. Otherwise, we wouldn't, there'd be values you couldn't find the inverse sine of, and that wouldn't make any sense. So since those are the domain and range of the one-to-one sine graph, when we go over here, the domain of arc sine corresponds to the range of one-to-one sine. So this is going to be negative 1 to 1. And then the range of arc sine corresponds to the domain of one-to-one sine. So that's going to be negative pi over 2 to pi over 2. So that's where that information is coming from. So you have to memorize it, but also think about it. Now, I find that the unit circle picture is like by miles the most common thing that I think of when I'm solving problems involving these. I draw it all the time. It's almost, I mean, you could still get something wrong, but I don't think you will if you remember to draw the picture. It's very, very helpful. So I recommend that. All right, let's deal with cosine. So again, copied this over. This is not though, so I want to be consistent in my shading here. So this is going to be the limited one-to-one graph of cosine. It is not the graph of arc cosine. We have not done the graphs of the inverses yet. So here, this is one-to-one cosine. The domain. So you actually, inverse cosine, or the one-to-one cosine, has actually the weirdest situation. It's the least like the others. So the other ones both use quadrants 1 and 4 of the unit circle. This uses quadrant 1 and 2. So that's like a little bit weird, but you know, nothing terrible. And then the range. So the range of this better be the range of cosine, otherwise we have messed up. So we get this. So then we go over here, and we're going to talk now about arc cosine. So these are actually about arc cosine. They're not about cosine. Although, I mean, everything about arc cosine is really about cosine. But so the domain of this corresponds to the range of the one-to-one function. So it's negative 1 to 1. And then the range of this, which is kind of the weirder one, corresponds to the domain of the one-to-one function. So this is going to be 0 to pi. And then when you look at the unit circle figure, I draw this all the time. It's going to be like the main motivator of me solving a lot of problems. I know that I can use quadrants 1 and 2 and that all the angles are positive. For arc sine, it's quadrants 1 and 4, but quadrant 4 has negative angles because it's got to be continuous. Like you can't get out of that little picture there. And then arc tangent, or dealing with tangent, this is 1-to-1. This is the easiest one, I think, like kind of conceptually of how you would come up with it. So this is 1-to-1 tangent. And what do we have? We have a domain, which is exclusive, negative pi over 2 to pi over 2. You do not include those because they're vertical asymptotes. They're not in the domain. You can't find the tangent of those values. And then the range is all reals. Y is an element of the reals. And so we go over here. What's my color scheme? I got this, I'm pretty sure. And then I can't remember. I don't know why I can't remember. It seems like it should be really easy. This, I think, is where we're talking about, yes, we're talking about the one-to-one graph of tangent, not the graph of arctan. We haven't graphed any inverse function yet. We're just trying to make sense of this stuff in a way that corresponds to what we already know. Because it's like trig is a lot of stuff to know. But if you realize that everything just keeps building, it's like really cool. It's like it starts out, in my mind, you start out with like a house of cards built on a bed of sand. That's like an expression for something that's like a terrible idea. It's a house of cards built on a bed of sand. But as you learn more and more, that sand kind of like gets it interweaves and whatever, and eventually you got like a house made out of cinder blocks built on a base of concrete. Like that's basically what we're trying to do. We're trying to like make everything make enough sense that like one thing supports the next thing, supports the next thing. So that's our logic. So the domain of arctan will correspond to the range of one-to-one tangent, which is all real. So the domain of this thing, you do the inverse tangent of anything. Pick whatever you want. You can find the inverse tangent of it. The range has to correspond to the domain of the one-to-one tangent function. So that's going to be -1. That's wrong. That's going to be negative pi over 2 to pi over 2 exclusive. So you do not count that. And that's why when you look at this little picture, we have open circles here. The open circles there are really important. They're like the most important part. I mean, you got to get the quadrants right and everything, but remember, you can't have negative pi over 2 or pi over 2. Those are going to be horizontal asymptotes of the graph of arctangent or inverse tangent. But anyway, this is a lot of information. So I'm going to stop this video here, come back in the next one. We're literally going to look at this stuff again in just like a slightly different light. So more to help us make sense of this coming up in the next video, and I hope to see you there.